Ya. Di supervisor Dr. Putra Sentosa. Just alone ini ya. Single ini ya, single single ya.
Iya, Pak, single supervisor.
Baik, untuk tidak memperpanjang waktu, maka kami berikan waktu lebih kurang 15 menit untuk Saudari Yunita untuk menyampaikan usulan proposalnya. Silakan.
Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
First of all, thank you for moderator that give me the time, and then thank you for my examiner, Mrs. Dr. Resti Rahayu, Mr. Dr. Adrian, and Mr. Dr. Afrizal, and then thank you for my supervisor, Mr. Dr. Putra Santoso. And let me introduce myself. My name is Yunita Astrina, and my BP number 1710422025. And in this presentation, I'm using English and in Bahasa. And now I would like to present you about my proposal research by the title Effect of Jicama Caseosus erosus fiber on insulin and fibroblast growth factor 21 levels in mice musculus fat with high fat diet under my supervisor, Mr. Dr. Putra Santos. Okay, as we know, in this era, so many people like to consume fat diet. If we are consuming fat more and more, its bad impact for our body health. And according to Hill et al. 2000s, high fat diet can induce obesity, and obesity could induce type 2 diabetes, hypertension, and certain cancer. And then obesity is imbalanced energy intake and expenditure, whereas your energy intake is more than your energy expenditure. And obesity is called fat in the body. And obesity could impact of our metabolic hormones like insulin and fibroblast growth factor 21. And obesity can induce insulin resistance. Insulin resistance is a condition your insulin is produced more and more, but your insulin receptor not responsible to the cells. And obesity could increase fibroblast growth factor 21 levels. Fibroblast growth factor 21 levels is endocrine hormone that metabolize our lipid and our blood glucose. And dietary fiber has been shown to exert a preventive effect against obesity, and several studies proven that increasing dietary fiber intake could reduce and increase our body weight. And according to Nurhamidah 2010, dietary fiber long time to be digested in the stomach, and hence dietary fiber prolonged satiety therapy preventing food intake. And then dietary fiber not digestible by digestive enzyme. It's about the previous research about dietary fiber. The first of all, there is Lee et al. 2016 that did a research about bamboo shoots fiber. Lee et al. Reported that bamboo shoots fiber could decrease blood glucose levels up to 43%. And then for Enhan 2015, a report also reported that Injicama fiber could increase insulin sensitivity. And Santoso et al. 2019 reported that Jicama fiber could inhibit the alpha glucosidase enzyme. This is the enzyme that catabolizes carbohydrate into the glucose. And then Santos et al. Also reported Jicama fiber precluded random and fasting blood glucose and sustaining glucose tolerance of high fat diet. In this my research, there is no finding about jicama fiber could preventing insulin resistance and could normalize the fibroblast growth factor 21. Whether the jicama fiber could normalize fibroblast growth factor 21, it's still unclear. For my problem formulation, the first, how does the effect of jicama fiber on the RNA expression of FGF21 in liver of mice fed with a HPET diet? And then, how does the effect of jicama fiber on FGF21 hormone level in mice fed with a HPET diet? And then, how does the effect of jicama fiber on insulin level and its tolerance in mice fed with a HPET diet? And for my research objective is the first to analyze the effect of jicama fiber on mRNA expression of fibroblast growth factor 21 in liver mice fed with a HPET diet, and then to analyze the effect of jicama fiber on fibroblast growth factor 21 hormone level in mice fed with a HPET diet, and then to analyze the effect of jicama fiber on insulin level and its tolerance in mice fed with a HPET diet. And for my significant research, it's expected scientific information concerning the beneficial effect of dietary fiber against metabolic disease and its associated health problem. And this is for my research, my time and place of the research. The research is conducted for months, started from May until August 2021 for the place Animal Physiology Research Laboratory, and then Biomedical Laboratory, Medical Faculty, Andalus University. This is for my instrument of my research. You can read in this slide. And then this is for the materials. You can read in this slide. And this is for my experimental design. I'm using completely randomized design with 4 treatments and 6 replication. First, group 1 is normal diet. For normal diet, I'm using Red Bio. It's a commercial livestock diet, PT Citra Ina Fat Mill Jakarta. And group 2, I'm using HPET diet. And group 3, I'm using HPET diet plus jicama fiber 10%. And group 4, I'm using HPET diet plus jicama fiber 25%. And the dose of jicama fiber 10% and 25% according to Santos et al. 2000.
Connection. Halo Yunita.
It is for acclimated for 7 days and then fed with commercial diet review and aquadis string at Libitum. And this is for the procedure jicama fiber extraction. The first of all, the jicama is collected in Kuranji, and then the jicama are peeled and then cut into the small and then blend with blender and soak for 16 hours after added aquadis 1 compared with 4. And then supernatant is taken. The supernatant is the fiber, and supernatant is peeled, and supernatant is steamed, and then placed into oven media, and then right into oven and packed into zip plastic, and then blend and start into zip plastic. And this is for my for the composition of my experimental diet. HPET diet 21%, 800 gram red bio plus 200 gram fat milk, and bar of dal is mixed, and then stir in closed place. And for the high fat diet plus jicama fiber 10% and 25%, for the 10%, 694 gram red bio plus 206 gram fat milk, and then added with 250 gram fiber and mix and stir in closed place. And for jicama fiber 25%, I'm for 540 gram red bio and added with 210 gram fat milk, and then 100 gram fiber and mix of all and stir in closed place. For the dose HPET diet 21%, and according to Yang et al. 2012. And it's for my animal treatment. The treatment will be conducted for 8 weeks. And this is for the group 1 and group 4 of my treatment. And maybe I have explained before, And then this is for my parameter of observation. The first of all, expression of mRNA fibrable growth factor 21 in liver by RT-qPCR according to Liu et al. 2019. This is for primer and primer part 1 and refers of my gen target FGF21, and this is for housekeeping gen beta actin. And the second table is the cycle of RT-PCR. RT-PCR pre-denaturation, denaturation until the extension. And this is for the procedure of my mRNA expression of fibroblast growth factor 21. The first of all, the liver is taken, and then isolate the RNA of FGF of liver and extraction methods by Trizon reagent. I'm using Life Technologies kit, and then synthesis for cDNA. I'm using reverse transcription system Promega kit, and then qPCR, and I'm using IT Cybergreen Supermix for BioReg. And this is for the result of the example of the result of RT-PCR. And the CT data is trend linear from a 2 square delta CT. And this is for the formulation of relative expression level. And then the second of my parameters of all, the blood is taken and centrifuge it at 3000 RPM for 10 minutes, and then the plasma is taken, and then standard dilution, dilute the standard dilution 120 microliter standard solution into 120 microliter standard diluent, and then standard is added to the well, and antigen or our sample is added to the well too, and then primary antibody is added, and add Horsteradis peroxidase enzyme to the well, and incubation for 37 degrees Celsius for 60 minutes, and then wash using a wash buffer three times, and then secondary antibody is added, and TMB or tetramethylbenzidine substrate is added to the well, and then incubation 37 degrees Celsius for 10 minutes, and then stop solution is added to the well, and the result is read by Alisa Reader. And this is for the third of my parameter, levels of insulin. The blood is taken and centrifuge at 3000 for 10 minutes, and then the plasma is taken and standard dilution, and dilute the standard, and standard is added to the well, and then antigen or sample is added to the well too, and primary antibody is added, and add HRP or Horsteradis peroxidase enzyme, and then incubation for an incubation at 37 degrees Celsius for 60 minutes, and washing using a wash buffer 3 times. And secondary is secondary antibody. I mean that this is secondary antibody. Secondary antibody is added, and tetramethylbenzidine substrate is added to the well, and then incubate with 37 degrees Celsius for 10 minutes, and stop solution is added to the well, and the result is read by Alisa Reader. Based on the result of Alisa Reader, it's quantified by the formulation. This is for the formulation of the Alisa Reader to analyze the hormone level of our hormone. And the last parameter is insulin tolerance test or ITT. The first of all, measure glucose levels, and then prepare the exogenous insulin and insulin 0.75 per kilograms body weight are diluted by acetyl phosphate buffer saline, and then the injections is preloaded with insulin and keep it on ice, and then the blood glucose levels is collected at 0, 15, 30, 90 and 120 minutes, and measure area under curve. This is for the area under curve is calculated by linear trapezium method with the formulations in this slide. And then for my data analysis, quantitative data are analyzed by using analysis of variance or ANOVA for each individual and each group. If the result are significant, then the data analyzed further by using Duncan's new multivariance test analysis with p less than 0.05 is set as significant. And this is for my activity timeline. And that's all for my presentation. Back to moderator.
Okay, thank you for the UNITA. You have for your presentation. Now we next the next session, yeah.
Yes,
that
sir.
was we give the chance to the give question for your proposal. We often please the student to give the question, yeah, comment for the UNITA proposal, yeah. Please. Any question? Please for all students.
Excuse me, sir.
Yeah. Yes. Go ahead.
I wanna give a question, sir. Okay. First is thanks to moderator has given me times to give to ask the presenter for this seminar. And my question is, UNITA, can you explain the FGF21 hormone mechanism and can you explain the mechanism of FGF21 hormones and what the no and how the high fat diet can influence the mechanism of FGF21 too. I think enough, sir. Back to
Okay, thank
moderator.
you. Son, yeah.
Yes, sir.
Okay. UNITA, understand the question?
Yes, sir. I understand.
Okay. Please comment, yeah.
Okay. Thanks to the question of Isan. Okay, I want to explain the the mechanism of FGF21 of HPET diet could block the receptor of FGF21. And if we are consume fat diet and fat diet go to our metabolism center like intestine and then and as we know the HPET the fat is as we know the central of the storage fat in our body is white adipose tissue, right? Or adipose tissue, and adipose tissue there now cannot maybe I wanna explain bahasa tidak bisa menampung lemak yang tinggi atau kadar lemak yang banyak di dalam tubuh, and as a result our fat go to into the other organs and other tissue like pancreas and then like a liver, and in the liver there is so many fat, and this is cause menyebabkan our FGF and as we know fibrous growth factor 21 is secreted by the liver, and then fat diet and fat go to into our liver, and the liver is blocked by the fat, and as a result, the fibroblast growth factor 21 is produced more and more, but the fibroblast growth factor 21 receptor, like FGFR1 or FGFR2C, is not responsible to the cell because the fibroblast growth factor 21 receptor is blocked by the fat, and after that, and fibroblast growth factor 21 increased in our body, increased in our body, and then the fibroblast growth factor 21 cannot respond to it, cannot stimulate the insulin sensitivity. This is for the complex mechanism of our metabolism of blood glucose and of blood and the F of glucose and for the lipid metabolisms. Maybe that's all from me, sir.
Okay, Insan, satisfied or
Okay,
not? Okay,
yes,
next.
think
Still
enough,
have?
sir. Yes,
Okay,
still
thank
have.
you. Okay, we next question, yeah. Please, any question, maybe? Please. There are 24 participants today, yeah. I think please give the comment for the UNITA proposal.
Ya, bisa bertanya berbahasa Indonesia kok, kalau ragu bertanya berbahasa Inggris.
Ya.
Bisa bilingual.
Tidak harus
ya.
bahasa Inggris ya.
Jadi nggak mesti
pakai
harus berbahasa Inggris. Kan bisa disampaikan. Kita
boleh pakai dua bahasa ya.
Iya, bilingual.
Jangan gara-gara bahasa jadi ini
Ada
ya.
pertanyaan. Takut ngomong.
Any question please?
Padilla, Firman, Gama, there are so many students here. Media, Mutia, Reva, Rosie, Salsa, Chika.
Please give the question ya. Comment is okay. Suggestion is okay.
Ya.
Izin bertanya.
Ya, please. Izin bertanya, silakan.
Terima kasih atas waktu yang diberikan oleh Bapak Moderator. Jadi yang saya ingin tanyakan yaitu ada perlakuan keadaan 4, Pak. Apa alasan dari penyaji menggunakan konsentrasi serat kalau salah ada 10% dan ada 25% tadi. Jadi apa landasan dari penyaji menggunakan konsentrasi segitu. Sekian, Pak. Terima kasih, Pak.
Baik, terima kasih. Ya, silakan ditanggapi Yunita. Kenapa harus menggunakan ini ya 10% dan 25% ya?
Iya, Pak.
Padilla? Oke.
Iya, Pak.
Oke. Next.
Okay, sir.
Silakan Yunita.
Okay, sir. I wanna explain why I'm choosing that 10% and 25%. And before, thanks to Padilla that asked me why I'm choosing the 10% and 25%. This is for I'm using the previous research about this research. It's according to Santos et al. 2021 that the G-gamma fiber 10% and 25% it's the good result of the insulin sensitivity, and then the blood glucose levels to the mice in the research of Santos et al. 2021. And why I'm using 10%? Because the 10% could increase the insulin sensitivity, but in 25% is the greatest of the concentration of the research in Santos et al. And this I want to treat how about whether the GCAMA fiber 10% and or 25% that the greatest result to insulin levels and FGF21 levels and expression. And maybe that's all from me, sir.
Oke, Yunita, mungkin supaya Fadila juga sangat paham, tolong diterjemahkan sedikit saja.
Ya,
Kenapa
ujinya.
Ujinya saja ya.
I'm so sorry. I'm so sorry, sir. Maybe I want to explain in bahasa. Jadi kenapa saya memilih GCAMA fiber 10%, 10% dan GCAMA fiber 25%. Itu saya mengacu kepada penelitian sebelumnya telah dilakukan oleh Santoso et al. 2021, di mana GCAMA fiber pada 10% ini menunjukkan sensitivitas insulin yang cukup baik, tetapi hasil yang cukup lebih baik dan lebih signifikan itu terjadi pada konsentrasi 25%. Nah, di sini di penelitian ini saya ingin mentreatment atau melakukan perlakuan bagaimana jika diperlakukan dengan 10% dan 25%, bagaimana efeknya terhadap hormon FGF21, kadar dari hormon FGF21 dan ekspresinya, dan bagaimana GCAMA fiber ini di 25% mempengaruhi pada FGF21 dan insulin dan kadar insulin di dalam tubuh mencit. Nah, mungkin seperti itu penjelasannya Fadila. Dikembalikan kepada moderator.
Oke, terima kasih. Bagaimana Fadila? Sangat paham?
Ya Pak,
understand?
mungkin cukup dipahami Pak, karena dari hasil penelitian dari Santo et al. Yang sebelumnya, walaupun konsentrasi 20% ialah yang terbaik, tapi mungkin Yunita masih menggunakan konsentrasi 10% karena menggunakan parameter yang berbeda. Begitu ya Yunita?
Iya, Fadila.
Oh, begitu ya.
Iya.
Oke.
Dapat dipahami Pak. Terima kasih Pak.
Oke, terima kasih Fadila. Ya, silakan next question for all student. One student again ya. Please. Okay, any question maybe? Please. Halo. Ini partisipannya ada 27 orang ini ya. Nah, coba salah satu dari yang hadir hari ini boleh pakai bahasa Minang pun juga boleh.
Iya, bahasa Jawa tapi kita nggak ngerti. Ini banyak ini, ada angkatan lain.
Ayo silakan.
Ada anak S2 juga Mas.
Ayo satu lagi. One anymore.
Okay, sir. Me, sir, Rosie, sir. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, I'm Rosina Frinda. I'm from Ecological Plants Laboratory. Okay, sir. I want to be questions for be explained. Why you choose for the subject object for the GCAMA? Okay, back to moderator. Thank you.
Okay, thank you. Yunita? Yunita, problem ya?
Koneksinya.
Connection problem ya?
Tinggalkan penyaji. Hilang sinyalnya. Coba saya telepon.
So wait a few minutes ya. The web is problem ya. Jaringan masalah.
Coba temannya ada yang dekat Yunita nggak? Oh, ini dia join lagi. Halo Yunita. Halo Yunita, itu ada joinnya di itu ya. Namanya ada tuh Yunita Astrid.
Oke.
Halo
Oh,
Yunita.
ini unit.
I'm so sorry, sir. My not working. It's not.
Oke, mungkin nggak usah pakai video supaya lancar. Hilang lagi dia. Ini kendala kalau seminar online ya.
Ya. Inilah Pak Putra.
Oke. Matikan aja videonya kalau sinyalnya lelet Yunita.
Yes, sir. Yes, sir.
Sudah oke?
I think okay, sir.
Oke, next. The question understand ya, Pak ya, Yunita ya?
Ya, pertanyaan Rozi tadi, tahu nggak?
I'm so sorry, sir, because I don't
Kayak gitu.
hear the question before. Maybe Rosie can repeat again the question, sir.
Okay. Okay, I want to be again try for my questions. My question is why you choose for the object jikama? Please your explain. Thank you.
Hilang lagi.
Aduh, gimana ini? Ada temennya enggak yang dekat sama Yunita? Echa atau Wilka? Elda? Halo?
Maaf Pak, mungkin tulisan tidak Pak.
Oke. Ada enggak yang dekat dengan dia di itunya? Dia di
Yes, sir.
sekarang. Hilang lagi sinyalnya. Ada yang dekat situ enggak yang ini rekannya?
Kalau nggak salah Elda, Pak.
Elda ya?
Ya, Pak.
Elda lancar aja, berarti kan bisa pakai ini sebenarnya, jaringan Elda. Halo Yunita.
Iya, Pak. Ini pakai jaringan Elda, Pak. Eldanya barusan. Iya, Pak.
Oke.
Terdengar suara Yunita, Pak?
Ya. Silakan direspon tuh pertanyaan si Rozi, sudah 2 kali dia bertanya.
Aduh, hilang lagi ya.
Timbul dia. Padahal dari pasar baru dia lokasinya. Kan bukan lokasi yang suka sinyal ya. Ternganga lah kita di sini jadinya.
Maaf, maaf, Pak. Apakah suara Yunita sudah terdengar, Pak?
Iya, iya. Silakan ditanggapi atau belum nyimak tadi pertanyaan Rozi.
Oke, Pak. Okay. Okay. Maybe thanks to Rosie, and I want to explain the answer. Why I'm choose the jicama fiber, and I'm just the jicama fiber because the jicama contain the beneficial effect of our metabolism, like including inulin, fibers, and then not digestible but by digestive enzymes, and in our large intestine. Then the inulin is a beneficial effect to and the previous research, Santoso 2019 reported that the jicama could inhibit the alpha glucosidase enzymes, thereby reduce postprandial glucose.
Hilang suaranya. Gimana ini Pak?
Jaringan problem nih.
Ada punya jaringan alternatif nggak yang di sana membackup-nya?
The enzyme is the enzyme that catabolize a
Hilang lagi suaranya ini, Ta.
Ya, jaringan buruk betul sekarang ini Pak Bud.
Ya.
Saya pakai 2 jaringan ini.
Seharusnya 2. Di sini oke aja sih.
Ya ya, Pak Bro aman ya.
Eca, coba backup Eca. Jauh ya kosannya ya?
Maaf Pak, Eca lagi tidak dekat Yunita Pak.
Siapa yang dekat sana? Si Elda?
Iya Pak, Elda barusan di sini Pak, tapi Elda keluar.
Ini kenapa ada MS Team ini? Mana kita mau melanjutkan seperti ini? Halo Yunita. Kayaknya kita menunggu nanti ya. Nggak kedengaran suaranya.